of the most important part of equilibrium is the equilibrium expression, which is the numerical value for equilibrium. Equilibrium expression. Or as we know, we just write it as KEQ. Now, to find a KEQ, let's use an example to demonstrate it. Let's say you have a reaction of what would the KEQ be? The KEQ equals to the concentration of products over the concentration of reactants. Therefore, it equals to this will be the KEQ value here. Note, some important part is that the bracket means molar concentration. The molar concentration unit is in molarity, which is by the big M. And then also is like the coefficient here will become exponents. All the coefficients here will become exponents here. As you can see, the C is to the C, D is to the D, A to the A, and the B to the B. And another thing you have to memorize is that the product, which is here C and D, will always to become part of the numerator, which is at the top, and then the reactants, which will be at the numerator, which will, the reactant will be the denominator, which is at the bottom. And finally, one of the other most important part for the KEQ expression is that we do not include solid or liquids. Everything we do for the KEQ for the equilibrium expression is for either aqueous solutions or gases. Alright, moving on to for the KEQ. For KEQ, there are multiple different types of expression. The most common one is probably the KC, which will just equals to molar. It's a constant for molar concentrations. Molar concentrations. Concentration C for concentration. Another one is the Kp, which is the constant for pressure. As we said before, we don't have any solid liquids, we only accept aqueous solution and gas. Because gas will have the pressure. Ksp equals solubility of product. Which importantly has no denominators as the product, as the reactant is solid. And these are the three most common ones we use for KEQ. For the future reference of units of acid and base, you have the Ka, the Kb, and the Kw. The Ka is the acid dissociation for weak acids. Kb is the base dissociation for weak base. And Kw is just the ionization of, is the value of ionization of water, which is just 1 times 10 to the negative 14. But we don't need that for now, because this is more towards acid and base, and we're just counting through for equilibrium. So this is for the equilibrium expression. I hope this has been helpful for you. Thank you.